ado, I'm Aaron Tinsdale and Select Projects, Spring 2019, and my project that I chose to attempt to accomplish is a guitar process and preamp multi-effect rack unit. So, you know, as a musician myself, homemade guitar effects pedal. Usually they're made, you know, several different brands of guitar effects pedals, you know, banded together with all their own supplies, bolted down to a piece of plywood. Essentially, the problem with this is, if you're playing as a musician and you want to make any adjustments to any of these knobs, you're having to kind of stop playing and bend down to do knob adjustments, and as well, because of these each has their own power supply, they create a ground loop issue, which takes in noise and creates humming and screeching issues when the sound effects are being used in different combinations. So, existing technology in the way, this is a Digitech head is the brand, and this is a modeling unit, has several effects. I believe it has 1,000 effects. Problem with these is the majority of them, A, don't come with a foot switch, and B, if you have two desired effects that are far apart from each other within the menu, you have to scroll through an entire menu to go from one effect to the other. It's not very convenient. These are more for, a lot of people try to use them in live applications, but they're better for like recording. So I figured I would take a conventional rack system, travel case rack system, which I brought in here. This is a much bigger one. As you can see, can hold a lot of units. This Digitech unit is a single slot unit. My unit will actually be taking up 2 slots in a travel case. So yeah, essentially my idea was to be able to take conventional hardware travel cases and make a system that's similar to this stage lighting control unit. So it's all foot switch controlled, but any adjustments were actually built into the head unit. So this was a basic system diagram of what I was looking to do, is essentially build an effects head unit that would sit up on top of an amplifier with its own foot switch and run off just a 9-volt power supply, because that's what all other distortion and effects pedals run off of. So this was a system diagram of the inner portion of my head that was just essentially my initial concept. This is what it ended up evolving to. So I've got a board unit that will house a microcontroller, a voltage regulator, and pin housings for relays to control separate effects boards, so I can have multiple effects all built into one head unit, controlled by a foot switch that talks to a second Arduino down in the pedal assembly through what are known as soft serial ports. This was a hand-drawn schematic of the module I was going to 3D print for a foot switch. I ended up using the module that we had here on campus, and as you can see here, I've got it mostly assembled, but I still have some kinks to work out. So here is a photo of the pedal mechanism. I'd say 95% finished. For this Arduino, I have my code working and controlling my LEDs and my switching mechanism the way I want it to. Now it's a matter of just writing some code for the serial ports to talk to the Arduino that will reside in the head unit, and essentially control the relays to do the switching from effect to effect, or just to have them all off in bypass mode. So here's the schematic of my foot switch board. The three pole double throw foot switches, controlling, going to 3 separate pins on the Arduino, and then these coming out to control either a red or a green LED. So each switch, above each switch is an LED. If the red one is on, that means the effect is off, or if the green LED is on, that means the effect is on. Here's my PCB layout for that. And so through the 2 soft serial ports into the USB, there'll be a board in the head unit that will house the second Arduino, which will then transmit out of 3 pins to some 2-terminal screw terminal ports that will go to a separate relay board that will actually trigger, that will actually physically switch between the bypass mode or effect mode. So here's a photo of the relay board that I'll be using, and essentially I'll be using 3 of the relays on this board and 3 of the relays on a second board. Can you go back a couple slides? Back. Right here. So essentially, you'd have to imagine where each of these relays is having a second one stacked on top. So when this relay, the signal will be coming out of the preamp, and it can either go into the effect board or it could go just through the relay. And essentially, if all effects are off, it's just a bypass circuit letting it be in a clean mode. And the second relay for each effect will essentially switch off the 9-volt power supply to the effect for power saving purposes. All right. So in the beginning, I had pulled these designs off of the internet in hopes of making these be my 3 effects. Essentially, though, they were basic designs that I could use as a template, but I had to really end up doing some retooling. So here's my updated preamp circuit. One of the things that I'd found out in my research versus simulated is I had thought I had a 1/10 of a volt input from the guitar. Come to find out, it was much, much lower than that because of the internal impedance of the guitar. So I had to redesign a circuit with essentially a source impedance of 20,000 ohms. And after some research and some assistance from professors, we got to this design that actually gives me, takes a 2 millivolt signal, and it boosts it up to the 1/10 of a volt that I needed to make my clipping circuit do the clipping and create the distortion I was looking to get. And after all the retooling, it worked perfectly. So here's the schematic from EagleCAD for my preamp circuit, and then here is the PCB layout. I have these boards printed, but I've yet to assemble them and install them. So that'll be coming soon. So this was my original distortion circuit that I had worked on in Multisim, but this has also evolved. So I decided to go a little more simplified, and I ended up getting a really nice sound out of it. The circuit that I ended up building for the distortion, you can see a picture here of how it does the clipping, but the sound itself actually sounds like a very old, like classic rock type of distortion. And so I was pretty impressed with how, in this case, simpler was better. And so here's a photo of a breadboarded version of my preamp circuit and my distortion circuit. And this picture was taken as I was testing it and actually playing guitar through it. here were some of the projected parts and associated costs. Unfortunately, a lot of the things that I have resourced to build this, like the angle iron here that's assembled the rack unit to hold all my circuitry, was perforated angle iron that I had stored. You know, I had it kicking around. A lot of other parts and pieces were things that I had kicking around. So for me to determine an accurate final cost to build this, I would have to go back through and re-engineer some things to essentially be able to generate an accurate cost projection. So here's another shot of my effects head unit rack that I had assembled. At one point, it was completely held together by self-tapping screws. I recently brought it to a machine shop and had it all welded because I was having trouble having it fit into the rack assembly unit, the travel case, and so after having it welded, everything fits perfectly. So I've got that already. And that's it. Any questions?
Can you go back and talk a little bit more about the communications and what it is exactly you're trying to do with the foot pedal switches and how they affect one relay?
Sure,
Can you
sure.
walk through that?
If you want to go back a ways. So essentially, the foot pedal unit will be transmitting on the.
So that's not the foot pedal.
This is in the head. This is in the head. So we've got a USB jack that goes down to the pedal unit, and so if you want to scroll forward. So essentially, this Arduino is programmed with if-else statements, so that if switch 1, the purple rail, is triggered equals a 1, then it will actuate the green LED. And then, so just using switch number 1 as an example, when it switches over from the red LED to the green LED to indicate that the circuit is on, it will send a message along this yellow rail through the USB cable up to the head unit, if you want to. And so it comes in, receives it on pin D10, which is the receive soft serial pin. The Arduino processes the information. It will trigger D3, which is relay 1. Relay 1 will be attached to effect circuit 1. And essentially, when that's triggered, it will switch from bypass to sending the signal through. So back to the head unit one. Yep. So essentially, when relay 1 is triggered, it will connect the effect 1 circuit into the loop and allow only effect 1 to be on, but the other 2 effects to be bypassed. And essentially, having it set up this way can have it so that you can have any effect, any single effect, any combination of effects, or all 3 effects on or off at any time. And so obviously if all 3 switches in the foot switch are red, off, then the wiper of each relay would be up. Just taking it from your preamp, which is just boosting your circuit from the high impedance of the guitar, and it just bypasses it back through the out jack. So it's just clean. There's no effect added to the signal. Is that what you were asking?
Yeah, that's fine.
Anyone else?
Any other questions?